Hello, my name is Solomon. I'm a student of robotics at Middlesex University. I want to make a presentation on my mobile robotics module coursework assessment, where I was required to perform some operation using the ROS, the robot operating system, and the turtlesim environment in ROS. And these are the operations I was required to perform: teleoperation, autonomous navigation, avoiding wall collision avoidance, vacuum cleaning, then spawning different turtles, yeah, to the different operations. So for my solution, I basically just use three different turtles all at the same time for all the operation. And so these are my nodes: the goal, py, spawn, sweep, tally up. So the spawn node is basically to create two turtles, because when you launch the turtlesim node, it automatically gives you one turtle. So I basically just use this to create two turtles. So, and these are my launch file for the three major nodes. I'm gonna explain the tally up node first, and basically this node, I'll go to the main function, where I I initialize the node and give it a name, and then I defined my publishers for the different turtles, my velocity publishers, and then this while loop keeps running forever until the terminal is shut down. So the keyboard input function gets the input from the user and sends it to move turtle to perform the required operation that we need it to perform. Right. So one interesting thing is this function that I used to perform the wall collision avoidance operation as the turtles are moving. So I'm gonna launch the launch file. Press launch. Robot package. Robot.pkg is the name of my package. And tally up launch. So it's gonna bring out the turtlesim environment and the different turtles that I want to control using the keyboard. So I'm gonna control the first turtle and move it forward. I'll move it backward. I can move it left. I can move it right. I can go clockwise. I can go anti-clockwise. So I'm going to try to collide with the wall and see what happens. And see that automatically tries to avoid the wall as it goes. It just reverses the movement just as it is in the code. So I'm gonna, okay. So I'm gonna try to control the second one, which is O. So I can move O that way, I can move it that way, I can move it that way, and do any movement basically that I want to do. So the collision avoidance is working also for this. Let's try and go diagonally and see what happens. The same thing happens. It's just really tries to move it. So I'm gonna go to the turtles, which is turtle three. So let's try and collide with the wall down over there. Okay, so let's see that uh, code seems to be working pretty fine. So I'm gonna try to um move the three turtles, right? So let's move them at the same time. Move the backward, turn turn them all with the same movement, turn them to same movement. So we can see that the tally operation function seems to be working pretty fine. Um, so I'm gonna close that. So C for stop. Gonna close that. Um, close it. Trying to terminate the I didn't want to terminate. So I'm just gonna create another tab and close it. Don't know why it won't terminate though. It usually does. But so I'm gonna go to the next one, which is my go node code.py. So this is basically um to send any of the turtle to a particular point that I wanted to go. Right. So I have let me go to my main function. Main function basically just the first one is trying to specify which of the turtle I want to move. Right. So yeah, I'm only moving them individually, not all at the same time. And then uh my move turtle functions. And in my move turtle function, well, first thing I set pen down, pen of the turtle that I want to move. And then I some maybe down already anyway. So I just want them to be in the same point, right? And then I publish the the twist, the velocity commands, right? To I publish it to which of the any of the turtles that I intend to move. So I get the correct position of the turtle, I calculate the distance of travel. So um I used a particular formula to be able to get this distance, right? Basically just getting the coordinate, yeah, calculating the distance, and then I moved it using this, get the angle. Then I now got this formula um in my research to be able to just go straight in a very smooth movement. So it's going to give me a very good smooth movement until the distance is less than 0.1. Right. So I also limited the angular velocity, so because I don't want it to um and also limit the linear velocity. Don't want it to be too fast. I don't want it to move too fast. So I'm just gonna run my node. ROS launch. I was supposed to show the accuracy graph, or maybe I'm gonna do that later. ROS launch. Um, robot package. go.py. Oh, sorry. I'm sorry, ROS launch, go.launch. Sorry. So I want to move, let's say I want to move the first turtle, turtle A, and I'm going to specify coordinate that I want it to go 7, 9. Right. So yes, I want to move that to B. I want to move it to 3. Let's say 3. And C7. So I want to move that to C. 6, 8. Just some random movement. So this solver basically is what is ensuring that I get good and smooth movement for calculating the angular difference and getting the appropriate um, velocities both for linear and angular velocity. So I'm gonna go to A. Let's say I still want to move the A to another position. 9, 3. It's moving graciously to the point where I asked it to move. Okay. So let's say I want to move C. I don't know, maybe let's go towards the edge of my stuff. That's nice. So I want to move B, give it another movement. Say, okay, I want to try to go to the other end of the environment. So that shows that my code can perform the action of moving autonomously to a particular place, given the coordinate where it is required to go to. So, oh yeah, I want to show just, just a moment. Oh, maybe we need to do that later. So, for the final node, which is the sweep.py, very interesting. In this node, I try to perform the vacuum cleaning operation using the using the vacuum cleaning operation, like using the turtles to sweep all around the environment. And basically, I'll go again to my main function. So I declare some, okay, I first initialize the node, of course, which I term random movement with wall avoidance. And I declare the global variables. Yeah, I needed this in order to get the position. And I need to declare them first to give them an initial value. The code will not run. So basically move them one after the other, 1, 2, 3. And yeah, and I start a random motion for each of them. So basically just start the node. So I'm gonna go to my random motion um, function, random motion with all avoidance. And basically, we're publishing the the velocity. I'm also trying to get the post, get uh, subscribing. Yeah, sorry, the post um is subscribing to what we're publishing. Sorry, right. So I try to increase the pen size using the set pen, and I change the color to black. Right. So which is 000. That's what I used to change the color. So this while loop is basically to avoid collision with each other. So if there is no collision, it checks for collision. And how does it check for collision? It tries to, you know, for this one, we're checking the total one after the other on the while loop. It keeps checking them. So it goes check one, check two. So if it's checking total one, it uses this distance um to calculate distance between the total and each of the all the totals, right? So if there's collision, send the Boolean value of collision to true. And if it is true, I use this to um, move the particular to change the direction of the one that we are currently checking its coordinate and its distance right against other ones. So I also use this to do collision avoidance, basically just changing the direction if it is too close, right? So uh, I'm gonna um, I think that's basically all with my code actually. So I want to run it, and first after running, I'm gonna show. So I'm gonna launch the code. So when I will launch it, it press launch Robot package um, sweep dot launch sweep dot launch. So it moves one, it moves two, it moves three, and they graciously try this. This is the obstacle avoidance. They're also avoiding themselves as they move, right? So after a couple of movements, right, I was able to generate something like this and this picture. Um, this particular picture where the whole thing is almost swept, and then this also. But I had a problem with my code, yeah, with the wall of avoidance and more collision avoidance and obstacle total avoidance. Um, and you see that there's some discrepancies, some collide in some particular places and different tests that I did. Right. And I think um there's something wrong with my wall collision avoidance, or not that there's something wrong, but I think you need to use some PID to be able to perform that avoidance efficiently, because that usually happen when there are two turtles close to each other and also close to the wall. So it kind of get confused, and one of them just run into the wall and keep rotating until it moves out of the wall. And yeah, so that's basically what's going on with this one. Right. So, and couldn't solve that, but it quite performed the function of vacuuming efficiently, and it was able to sweep around. So I'm going to show the the equity graph to see what's going on. Equity graph. Um, So let's go to all the nodes. These are the two major nodes. Just the random motion, sending velocity, right? Publishing velocity to the turtle sending to the post, and we can see that also in our code, right? Velocity is being published to the turtle. The post subscribe to it, right? And also, um, yeah. This shows all our topics. Each turtle trying to get the post, trying to publishing the velocity to each turtle one, turtle three, and them getting sending back the post right to my node so that it can perform wall avoidance. That's the main reason why we need the node for total and wall avoidance, which was quite effective, but not as effective as I wanted it to be. But it performed the function quite well. I see that the whole thing is almost filled, right? And um, that's it. So I think I should just show the accuracy graph of the all the nodes. ROS launch robot package. Ready up, launch. So let's see what's going on under the hood. The accuracy graph. So these are the nodes, right? The tally up node. Here we are just publishing everything related to the total with the yeah, we're just publishing to the total, right? So for the topics, publishing the node to publishing these topics to the node from tally up, right? Each of them, total one, total two, total three. And something similar is in the other code also. Um, so I still have problem closing this. I don't know why this happened. So I'm gonna go to this, to the go. Oh, sorry, go.launch. Right. Let's see what's going on. Yeah, so it is in the code, right? It only publishes when we ask it to. So it's only when I specify something that this is going to change. But if I don't specify anything, nothing happens, right? So if probably it's gonna move already before. See, while it's moving, the topic is being published, right? But after movement, it's not going back. So that because I published 31, so if I move 32, we say I will expect that this is going to change, right? So then if I move 33, see, um, so this should change also. Yeah, so that's basically, yeah, we are also subscribing to the post, yeah, subscribing to the post. Yeah, because that's basically what um to know the particular point where it is at before we start our movement, right? So publishing topics to publishing um topic to the turtle, getting the buzz from the turtle. So I think that's um a brief um explanation of what my code is all about. And I've been able to show everything that's going on. Thank you for listening.